In this video, I'll talk about relative motion and then solve practice problems in relative motion in one dimension. So I'll advise that you don't skip around this video. In the next video, I'll talk about relative motion in two dimension. Alright, let's say a body moves from point A to point B. If you want to define the distance between the two objects, of course, motion has already occurred. The body moved from point A to B. Let's say you want to define the distance between the two objects. You may need to, between the 2 points, you may need to define it with respect to these 2 points because every other definition might be a loose one. It simply means that motion does not happen in isolation. It happens with respect to two or more things, which are referred to as the frame of reference. Now, let's say you are moving, let's say you are in a car that moves 20 meters per second. You are in a car that moves 20 meters per second. And then you have a brother that moves in his own car at 30 meters per second. The 20 meters per second you are moving at is your velocity relative to the ground, while the 30 meters per second in this case is his own velocity relative to the ground. Now, your relative velocity the relative velocity of your car to your brother's car is 10 meters per second in the opposite direction. I'll explain how we arrive at this in this video. Now, let's talk about, before we talk about relative motion in one dimension, I would like to define the word frame of reference. The frame of reference or reference frame is the coordinate system in which the position, the velocity, and the acceleration of an object that is either moving or at rest is measured. For instance, this 20 meters per second is the velocity of this car. So I can say it again by saying the 20 meters per second is the relative velocity of this car to the ground. That is the relative velocity of the car to the earth or to the ground is 20 meters per second. In this case, the ground is the reference frame, or the frame of reference. That is, it is the coordinate system in which the velocity of the car is being measured. So we can know the position of an object, we can know the velocity or the acceleration of an object in a coordinate system. Such coordinate system where we measure those physical quantities are called reference frame. Now let's talk about relative motion in one dimension. The relative motion of an object in one dimension is simply talking about for instance, let's suppose the case of you and your brother. So this scenario is a relative is an example of a case, is an example of relative motion in one dimension because the both observer, that is you and your brother, you only have two possible directions. It means that relative motion in one dimension is one in which there are two possible directions. It can either be towards the east or towards the west. So it's in one dimension, that is two possible direction. Now, in this case, in this scenario, the let's suppose that you are moving in a train. Let's suppose that there is a train. Let's suppose that there is a train. If the train moves at 20 meters per second, and then there is a passenger inside the train, the passenger sitting inside the train when the train moves 20 meters per second. Let's say that after some time the passenger moves backward inside the train at 5 meters per second. At 5 meters per second. The the passenger has a relative motion with respect to this train. And that same that, okay, let's say this is the symbol for that. The passenger, the relative velocity of the passenger with respect to the train, t, okay, with respect to the train, t. The passenger also has relative velocity with respect to the ground. With respect to the ground. So let's say v, passenger with respect to the ground. The train, which is moving at 20 meters per second, I already explained that in the case of you and your brother, the 20 meters per second is the relative velocity of the car, of the train, with respect to the ground. So in this case, the train, the ground are the frame of reference. But notice that the train and the passenger, they have a common frame of reference in this case. So we can find the relative velocity of the passenger with respect to the ground. We can find it using this formula. Velocity of the person to the train plus relative velocity of the train to the ground. Okay, it is easy to find the relative velocity of the person, the passenger, with respect to the train because he moves 5 meters towards the west while the train moves 20 meters towards the east. If we want to use the vector representation, if we want to represent them using the vector symbol, we can say that the 20 meter per second, we know that that is the relative velocity of the train relative to the ground. The train relative to the ground, which is given as 20 meter per second. Let's say it is along the positive x-axis. If we call that I, so with respect to I, if I say that the relative velocity of the passenger with respect to the train, the relative velocity of the passenger with respect to the train, which is supposed to be 5 meter per second, that will be minus 5 meter per second. I shows that it is with respect to the positive x-axis. So this minus shows that, okay, the 5 meter per second is in an opposite direction to the I, which is the positive x-axis. So 5 meter per second moves opposite to the positive x-axis. It is towards the negative x. So why this is towards the positive x-axis. Now this formula should be noted. This formula should be noted. Now, you should, in this case, the arrangement of this matters a lot. The arrangement matters a lot. If you notice, we have T goes to T and then P goes to G. G, so we can say that if we have P and G, that is person and ground. If we have P and G, so the subscripts will be P to T and then T to G, that is from P to a particular place which is T, and then from T goes back to G. So you should be able to memorize this formula, and then don't forget the positive sign. This formula can also be written as VPG equals the relative velocity of the person relative to the train, that is VPT, is minus the relative velocity of the ground. So you can do this. The reason is because VTG, the relative velocity of the train with respect to the ground, is equal to negative velocity of the ground with respect to the train. So the source script changes, it requires a negative sign. So in this case, what we simply have is something of this nature. We can say that VPG is equal, instead of having VPT, we already have VP. Okay, let's say VPT. Then since we know that the velocity of the train relative to the ground, if we interchange the source script, it will bring about a negative sign, which is the relative velocity of the ground with respect to the train. So I can rewrite relative velocity of the person with respect to the ground is equal to Vp minus Vg. So some text writes this formula this way. So no matter what, anything you may have, relative velocity of x to y can be relative velocity of x then y, or you can have x y, which is equal to the relative velocity of x to a particular frame of reference, maybe p plus v p y. So don't forget, you may also have instead minus then v y p, or the other way around. So finally we can say that the relative velocity of the person with respect to the ground is equal to the relative velocity of the person with respect to the train, and don't forget that is minus 5, because with respect to the train, the person is moving backwards. The train is moving towards the east, 20 meter per second, but the person inside the train stands up and then move backwards. So with respect to the train, the person is moving at a negative direction, so that's why we have minus 5. So the with respect to the train, the person is going in another direction, which is opposite to the train. So if the passenger had moved forward, it will be plus 5. But the passenger didn't move backward. The passenger didn't move forward, he moved backward. So that's why we have negative 5. So plus the relative velocity of the train with respect to the ground, that's just 20. So it means that the relative velocity of the person with respect to the ground is 15 meters per second. Positive. So you can either use this formula this way, or you can use it this way. Just know, be able to define your terms. That's just the key. Alright. A jet cruising at a speed of 1000 kilometers per hour ejects hot air in the opposite direction. So it's just like the case of the passenger moving backwards in a moving train, just like the former example I cited. All right. Now the jet that is cruising has this velocity, so we can say that the velocity of the jet, we can simply say the velocity of the jet, or we may say the velocity of the jet with respect to the earth is equal to 1000 kilometer per hour. Now that same jet ejects hot air. Let's say it moves something like, we have something like this. So, and this is the hot air in the opposite direction. So we can have something of this nature. So the jet moves this way, velocity of the jet to the earth, and then this is the velocity of the hot air, let's say A for air, with respect to the jet, because the hot air is actually coming out from the jet. So don't forget that this velocity will be negative, just like the case I described in the last scenario of a man of the passenger moving in the opposite direction. The train is moving this way. We said it's moving at 20 meter per second, and then I said the passengers moves backwards inside that train. So that's negative 5. The reason is just because with respect to the train, that person is moving backwards, so it's negative. So in this case, the hot air with respect to this jet that is moving in this direction, with respect to this jet, the hot air is moving at a negative velocity. So the speed, if the speed of the hot air with respect to the jet, nice. So we can say the velocity or the speed of the hot air with respect to the jets. So that's AJ is equal to minus 800. To find the speed, let's find the speed of the hot air with respect to the ground. That's the question. The ground. So we don't need to use earth. In this case, we need to use ground. So to find the velocity of the jet with respect to the ground. Oh, find the velocity of the air, not jet, with respect to the ground. So ground is their common velocity. So how do we do this? So velocity of the air with respect to the ground is equal, I told you, is equal to the velocity of the air with respect to the jet plus the velocity of the jet with respect to the air. So you follow the trend. All right. So no, from the jet to the train, yeah, to the ground. So AG will always have it here, AG. So this will just have to follow each other. So just like I have in the former screen. So velocity of the air with respect to the ground is equal to this. Do we have the velocity of the air with respect to the jet? We have it as 800. So this is given as this. Do we have the velocity of the jet with respect to the ground? We do not have it. We only have the velocity of the jet. Oh, we have it. So we can just go straight. That means it's so direct. So we have minus 800 plus velocity of the jet with respect to the ground is 1000. So the answer is 200 meter per second. 200 kilometer per hour. I hope you understand. Alright, let's solve another practice problem. Okay, two cars A and B parallel moving at a parallel paths from a common point. Let's say this is the common point. If U and V be their speeds respectively, let's have A moving this, and in this case U is greater than V. That means U is faster, and then we have V to be somewhere here. So we have U, V, that's their velocities. Then find the separation between them after time t. The separation between them is this. This is the separation between them. Let's call it x. Now don't forget that velocity is distance, is displacement over time, or speed is distance over time. The separation between them, the word separation is the word distance. So we can say that the velocity or the speed is distance over time, is the separation upon the time. So it means that the distance is velocity multiplied by the time. But in this case, we do not have the velocity, but we can find the relative velocities between the objects. We have object A, I mean car A and car B. We can find the relative velocity between car A and car B. So we can say that V is the relative velocity of car A to car B. You know the formula. The formula is VA. In this case, we can say with respect to the ground plus V in the ground with respect to car B, and then the velocity of A with respect to the ground is given as u. The velocity of the ground with respect to car B is not given, but we know this is, let's say this is VAG, velocity of the car A with respect to the ground, and then the velocity of car B with respect to the ground given as B, but we were not given velocity of ground with respect to car B. So but we know that it is the negative of the velocity of the car B with respect to the ground. I told you you always have to be mindful of the subscripts. So GB negative BG. As a result, I can substitute it into this formula so that I will have the relative velocity of A to B to be equal to velocity of AG minus velocity of BG. As a result, the velocity of car A relative to B is VAG, where VAG is U, then minus V. That's it. So in other words, the separation x, which is equal to VAB multiplied by T, is equal to U minus V multiplied by T. So this is the separation between them. Let's solve another practice problem. Don't skip around this video. Alright, so if two bodies at constant speeds moves towards each other, if they move towards each other, the distance between them, so if two objects are moving towards each other, then the scenario should be something of this nature. They are moving towards each other, and the separation between them, it's decreased at a particular velocity. So we can, let's say this is body A and this is body B. In this case, body B is moving in opposite direction, so we can say that the relative velocity between them is 6 kilometers per hour as given. Now if the bodies move in the same direction, if they had moved in the same direction, let's consider it this way. So this is body A and this is body B. If they had moved in the same direction with the same speed, the linear distance between them increases, so at that rate, which is 2 kilometers per hour. Alright, now find the speed of the two bodies. Now the question is to find VA and then VB. Note that when a body moves and the question says the velocity of that body is probably p meter per seconds, it means that p meter per seconds is the relative velocity of that body with respect to the ground or to the earth, anyone. So we can say that the velocity of A is the same thing as velocity of A to the ground, and B is B to the ground. Alright, so in this case we have been given the relative velocity of A and B, and of course the formula is this: the VAG plus VGA, oh sorry, VGB. So it goes from A to B, then GG. Velocity of the ground to the body is the negative of that of the body to the ground. So, and of course that means velocity of AB will be velocity of A relative to the ground minus velocity of B relative to the ground. But note that VB is in opposite direction, is moving in an opposite direction. So since VBG moves in the opposite direction, it becomes negative. That means the relative velocities will be VAG minus and then minus, so which is the same thing as positive VAG plus VGB. bg, which is given as 6 kilometers per hour. Let's call this equation 1. And then, considering this, the two bodies, they move in the same direction, and if they move in the same direction, that means they will be positive. Both sides will be positive, so we can say that the VAB, which is 2 kilometer per hour, from this formula, the VAB, which is always equal to VAG plus VGB, but in this case we don't have VGB, we have VBG, so we can use the VAB, which is equal to VAG minus VBG. And of course, that's it, because this move in this direction, this also moves in this direction, so they are both positive and positive. So the negative sign is because we don't have VGB, we have VBG. And of course, it has been given as 2. It has been given as 2. So let's call this equation 2. So if we solve equation 1 and 2 simultaneously, like this, VAG plus VBG is 6, and then VAG minus VBG given as 2. So if we subtract both sides, then this cancels out, so that this and this gives us 2VBG, which is equal to 4. That means the velocity of the body with respect to the ground is actually 2 meters per second. So this is 2 meters per second. And then to find VAG, we just need to impute 2 in, we can put 2 here, so that means that will be, then VBG will be 6 minus 2, which is 4 meters, no, kilometer per hour. So this is supposed to be kilometer per hour, so we'll have 4 kilometer per hour.